Good day, students. Now we're going to look at the solution to the first long answer question from your Chapter 5 sample quiz on logarithms. This is book 2 of your ma1026 booklets, and it's asking us to solve the following equations. Now we'll just do the first one on this video. So let's look. We got log of base 5 of x plus 4 subtract log base 5 of x minus 2 equals log base 5 of 25. Now, in order to solve this, there are two types of log equations. So, right, in order to solve this one, notice it has logs on both sides. Each term is a logarithm. Okay, when you have logs on both sides, we want to drop the logs. But before we can drop the logs, we have to have it like this. We have to have it logs of some base m, say up to base b, equals log base b of some value over here, we'll call it n. If you have it down to a single logarithm equal to a single logarithm on the other side of the same base, so if you have this, then you can say m equals n. In other words, you can actually drop the log part and let this equal this. Okay? So, but before we do that, we have to have a single log on each side. There we have a single log and a single log. In the equation we have, what do you notice? On the left-hand side of the equation, we have two logs. This is not a single log. So we can't drop the logs yet at this stage. Okay, so we're working on this idea, and we're going to see if we can make the left-hand side a single log. The right-hand side is already a single log, right? Okay. Now, we've used a few rules. One rule you have to apply first is that if you have this, a log base b of m, in other words, if there's a coefficient in front of the log, that has to be moved first. Log, oops, let's write that down, log base b of m, and move that exponent up there, right? Now, check for exponents. So what do you see? Other than 1, check for coefficients. Nope, I see nothing. So we don't have to apply this rule first. So check and make sure. Alright. Next thing, once I've checked that, now I'm going to bring these together as a single log. So, now the rule I'm using, of course, is what? If you have log base b of some value, subtract log base b, same base, of another value, of course, that means you can divide those, right? Called the quotient law. So these over here would become log base 5 of x plus 4 over x minus 2. Now I have, see? Now it's a single log, isn't it? So now that I got a single log on both sides, I can apply this concept, right? The fact that a single log on both sides of the same base, meaning I can drop those logs and say, therefore, x plus 4 over x subtract 2 is equal to 25. So I basically drop the logs. Okay? Now, how do you solve that? Well, you've solved equations like this before. So we got x plus 4, x minus 2, and over here we got 25, which is understood to be over 1. And we know to solve this, the method when we have a single fraction equal to a single fraction, we cross multiply. So 25 times x subtract 2 equals 1 times x plus 4. So that gives us 25x. Alright, subtract 50, right? And 1 times that, of course, is not going to change the equation. Now what happens? Well, I need to gather my x terms together. I got an x term on the left-hand side, I have an x term on the right-hand side. So I'm going to bring this over, or subtract x from both sides, whatever way you want to say it. And at the same time, I'm going to leave the plus 4 on this side. I'm going to bring this negative 50 over here, and that means I add 50 to both sides. Okay? So 25x subtract 1x leaves me with 24x, and 50 plus 4, of course, is 54. Now to isolate the 24, or isolate the x, I must divide each side by 24. And let's see what we get. X is equal to, so 54, oops, 4 divided by 24, or you could reduce it to a fraction, your choice. That's 2.25. Or you could have reduced it as well, right? We know each is divisible by 6, and you could have changed that to 9 over 4. So either or answer is correct. We've got 2.5 or 9 over 2.25 or 9 over 4. So there's the solution to that log equation. The next two videos will solve the other two log equations for you. Okay?